Hey guys, welcome back to Algebra 2 Lessons with Miss B. This is lesson 15.1, Logarithmic Functions, part 1. Okay, there are two parts to this lesson because this is an explanation more about what a logarithmic function is. This is very necessary information, but you will be doing more examples of how you solve logarithmic functions in the next video in part 2. Okay, so a logarithmic function is the inverse of an exponential function. So an inverse, you would write an inverse function as f to the negative 1 of x equals the function, okay? So basically what I'm going to do is I'm going to show you that we're going to do the graph of the log function, okay, which we're just going to take from this graph here. And I've written all the points out. So the points for the logarithmic function is just going to be this set of points reverse. So it's going to be 0.25 comma negative 2, 0.5 comma negative 1, 1 comma 0, 2 comma 1, 4 comma 2, and 8 comma 3. Okay, so I'm just going to go on my graph and put it on here. So 0.25 negative 2, so that's about right here. 0.5 negative 1 is right about here. 1 comma 0, 2 comma 1, 4 comma 2, and 8 comma 3. Okay, so you can see that these are opposites of each other. This is the inverse, okay? So I'm going to label this in a very clear. So this is the exponential, and this is the logarithmic. Okay? So this is just stating that if f of x equals b of x, b to the x power, okay? So this is the exponential. So exponential. Then the inverse is the logarithmic. Okay? So this is just another way of saying that the logarithmic function is the inverse of the exponential function. So how did we get the points for the graph of f to the inverse? Okay, so they plugged in 0.25. So they plugged in the y value and they plugged it in they plugged in the x value, to the log function. Okay, so they did on their calculator log base 2, 0.25 equals negative 2, after the negative 1 of 0, or the inverse of 0.5 equals log base 2, 0.5, which gives you negative 1. The inverse of 1 is the log 2 of 1, which gives you a value of 0. Inverse of 2 gives you a value of 1. The inverse of 4 gives you a value of 2. And the inverse of 8 is 3. Okay, so these values are what I used up here. Okay, that's this, 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 and this. Okay, so we are going to be converting between exponential and logarithmic functions. So the exponential function is b to the x power equals a, and the logarithmic is log base b times a equals x. Now, the key thing, that you need to know is that you are going, when you're converting, is you're going to take this and you're just going to replace it. And you're like, Miss B, drawing this arrow doesn't make any sense to me. What I mean by that is you'll notice that here, okay, I moved my B and it's basically just moving places. So my B came down to be here. My A got moved from over on the right to the left side, and my X got moved from the left side to the right side. So you can see that the B just moved. And to convert over back to the exponential function, you just draw your arrow, okay, and your b moves to back to b of x equals a. That is how you convert between the exponential and the logarithmic. Now, this may seem confusing right now, but we're going to do so many examples that you're going to be able to see this in real life. Now, the important thing to note is that the b always has to be greater than 0 and the b cannot equal 1. Those are two very important things that you must remember, okay? The b has to be greater than 0 and it cannot be equal to 1. You can write any exponential equation as a logarithmic equation or a logarithmic one as an exponential, okay? That's because these are inverses. So here we're going to do some examples. So this says that we're going to use 4 to the power of 3 equals 64, and they want us to write it as a log. Now remember, b to the x power equals a is our exponential, and our logarithmic one is log base b a equals x, okay? So I'm just going to label this for you, okay? So my b is 4, my x is 3, and my a is 64, okay? This is an exponential form, so I need to move it to log. So if you write it out like this, you now just have to plug it in. So log of 4, my a is 64, equals 3, okay? So if you write it out over here on the left as values, then you can just plug it into the equation. We're going to do another one, okay? 5 to the power of negative 3 equals 1 over 25. Okay, I wrote this down wrong. This is actually supposed to say log. Okay, so this gives, so what we're going to do is we're going to do b equals 5, x equals negative 3, and our a is equal to 1 over 25. So we write this as log 5 1 over 25 equals negative 3. That is how you would write that. For this one, it says that we have an exponential function and they want us to write it as a log. Okay, so we're going to take our values and we're going to identify them. So b is 2/3, x is p, and our a is q. So we're going to just plug our values in. Log of 2/3, okay, q equals p. Okay, so another example, the log of 1/2 to the power of m equals n, and they want us to write it as an exponential function. Okay, so my base is 1/2, my x is n, and my a is m. Okay, so I'm just going to plug it in. So my b, so 1/2, okay, to the power of x equals m. Okay, I'm going to do another example for the exponential function so that you need to show you that you can write it as an exponential one. So they give us log of 3 to 43 equals 5, and they write as exponential. Okay, so again, the exponential function is b to the power of x equals a. So I'm going to identify my b, my x, and my a. So my b is 3, my x is 5, and a is 243. So I'm now just going to plug it in. 3 to the power of 5 equals 243. Okay. I'm going to do another one. One more example of how you write it as an exponential function. Okay, so we're going to do the log to 1/5 v equals w. And they want us to write as exponential. Okay, so my b is 1/5, my x is w, and my a is v. So I'm just going to plug it in. I get 1/5 to the x oops, sorry, my parentheses got a little wonky. 1/5 to the power of w equals v. And that is how you write logarithmic functions and exponential functions and converting in between them.